So this is 6-3, part 2. We're just continuing the video. For these, we're going to be able to take out a greatest common factor for many of them. So don't forget that's the first thing that you should always try to do before you do any other type of factoring. So if I look at J here, does everybody notice that I can take a 3 out of all of the terms as a greatest common factor? So I'm going to go ahead and take out a 3, which will leave me with L squared minus 7L minus 8. And now I'm going to go ahead and I'm going to factor that. Now notice what's nice here is there's a 1 in front of the L now. So it's going to be a little bit easier to factor it. Remember, it gets dicey with the guess and check if the number in front of the L squared would be anything other than 1. So all this can do is split up into L and L. I need two numbers that multiply together to get negative 8 and add together to get negative 7. So that's going to be a negative 8 and a positive 1. Don't forget to include the 3 as part of your answer. K is a situation where factoring out a negative, I think, is going to help us. See how there's a negative number in front of the L squared? That's never a good thing. So let's factor out a negative 3 because that divides into all of the terms. That's going to give me an L squared. Negative divided by negative is plus 5L minus 6. I think this is going to go better. So here we go, two sets of parentheses. L squared will split up into L and L. We need two numbers that multiply together to get negative 6 and add together to get positive 5. Well, we're going to have a 6 and a 1. If they have to add together to get positive 5, it's going to be a positive 6 and a negative 1. Again, pause whenever you need to. Come back. Is there a GCF here? I'm looking, not for the numbers. I don't think so. So here we go. We're just going to go into guess and check, and this one does not look like it's going to be fun. So here we go. So 14a squared will be, 14 can be 1 in 14, or it can be 2 in 7. I'm going to try the 7a and the 2a first. I just have a feeling. All right, now we have to split up the negative 2. Well, that's going to be 2 in 1 or 1 in 2. So ignore the b for a minute, but if I put a 1 here and a 2 here, if I FOIL that back out, do you see outside I'm going to have a 14 and inside I'm going to get a 2? Is there any way out of a 14 and a 2 to get a negative 3? No, there is not. So let's try it the other way and put a 2 here and a 1 there. So now we'll get 14a squared. Outside we get 7 and inside we get 4. Can I get a negative 3 out of a 7 and a 4? Yep, but the negative 7 has to be there. So don't forget, because of this b squared, all that does is put a b there, and then this is going to be a positive 2b. So if I quick FOIL this back out, I'm going to get 14a squared. Outside I'll get negative 7ab. Inside I'll get 4ab. And what is negative 7ab plus 4ab? That's negative 3ab. That one's a little trickier. M, I'm looking at a GCF. I'm looking at a GCF of 3x. Let's see what it's going to look like when it comes out. So that's going to give me a 2y squared plus 11y minus 6. All right, so now let's do our guessing. Let's not forget the 3x. So bada bing, bada boom. So 2y squared, we really don't have a choice. It's going to be 2y and 1y. Now, if I look at how I'm going to split up the 6. If I split this up into a 3 and a 2, it's going to be hard to get an 11. An 11 is a pretty big number. So now I'm thinking 6 and 1. So what if I did a 1 here and a 6 here? Let's see what that's going to do for us. Well, if I FOIL it back out, I'm going to get 2y squared. Outside, I'm going to get 12y, and inside, I'm going to get 1y. Can I get an 11 out of a 12 and a 1? Absolutely. The outside 12 has to be positive, and the inside 1 has to be negative. And there you go. For n, again, I hate it when there's a negative number in front of my x squared. Even though I can only factor out a -1, I'm going to do it. Because I just think it's going to be easier for me. So now let's take my trinomial, and I'm going to have to guess and check here. So 5x squared's got to be 5x and 1x. Now again, 4 can be 2 and 2, or it can be 4 and 1. I need to get a 19. That's a pretty big number. So I'm going to do a 1 here and a 4 here. So see, these clues, if you really look, you can kind of analyze and realize that you're going to want larger numbers as opposed to smaller numbers. But again, these things come with practice. So let's check this out. So if I FOIL back together, I'm going to get 5x squared. Outside, I'm going to get a 20x, and inside, I get a 1x. I need a 19. So that means my 20x has to be positive on the outside, and my -1x has to be negative. All right. Oh, let's see. We've got more. Let's talk about perfect square trinomials. So you might remember, these hopefully look familiar. You might remember when we were back in chapter 5, and when we were squaring a binomial, I showed you a shortcut. And this was the shortcut. If I had to square this binomial, remember how you square the first term, you multiply the two terms together and double it. That gives you the middle term, and then you square the last term. So I showed you that. At the same time, I told you you really didn't have to do it necessarily. Okay, but again, it's also can be a shortcut for factoring. So I am going to go and I'm going to show you these next 4 problems by using perfect square trinomials. So here's how you check. So the question is this a perfect square trinomial? So when you're faced with a trinomial, is it a perfect square? Well, here's a quick test that you can do to tell if it is or not. What's the square root of the first term? It's x. So I'll usually put that right under here. Is the last term a perfect square? Well, yep. And what's the square root? It's 10. Now, as soon as you see a number that's not a perfect square here, then you cannot factor it as a perfect square, and you have to go ahead and do guess and check. So now, since both of these are perfect squares, if I multiply these together and double it, do I get this middle term? Well, x times 10 is 10x. Double that, you do get 20x. This is a perfect square trinomial. Once you've identified it, the point is it makes it easy to factor because it follows this form. So you can simply factor it as x plus 10 quantity squared. There's no guessing and checking, but you do have to do that check to see if it is a perfect square. Let's go ahead and let's look at this. Is this a perfect square trinomial? Well, I can take the square root of 9r squared. That's 3r. Oop, can I take the square root of 7? I cannot. This is not a perfect square trinomial. So now the question is, can it factor? Well, then you would go back to your guessing and checking. We have to split up the 9r squared. Well, it's either going to be 9 and 1 or 3 and 3. I'm going to try 3 and 3 again. I'm guessing. And now I have to split up the 7. It can only be 7 and 1. So let's try a 1 and a 7 here. So if I FOIL this back out, I'm going to get 3r squared. Outside, I'm going to get 21. Inside, I'm going to get 1. Can I get a 24 out of a 21 and a 1? I cannot. What if I flip the 7 and the 1? Is that going to make a difference? 7 and 1. Now, outside I have a 3, and inside I have a 7. Can I get a 24? I cannot. It doesn't look like it factors in any of our methods, which means that that one is prime. All right, let's move on to C. Again, what you want to do is check really quickly. Is it a perfect square trinomial? Well, let's do the check. Can I take the square root of the first term? Yes, it's 5x squared. Can I take the square root of the last term? I sure can. It's 2. If I multiply these two roots and double it, do I get the middle term? Multiplying them, I get 10x squared. Double it, I get negative 20. So absolutely. So now that I have identified it as a perfect square, I can simply factor it into 5x squared. Now, this middle sign is always this sign right here. So it's going to be minus 2 quantity squared. Finally, our last one. Look at this one. Do you happen to notice that we can take a greatest common factor out? We better do that. So what divides into all of these? What looks like it's just going to be a 2. So 4n squared minus 20n plus 25. Now, we have a trinomial. Now, you can immediately go into guess and check, and that's okay. But let's quick check, because it doesn't take but a second to see if it's a perfect square. Because I can take the square root of 4n squared, that's 2n. And I can take the square root of 25, that's 5. If I multiply 2n by 5 and double it, now when you're doing this check, you ignore the middle sign. But if I multiply these, I get 10n, double it, I do get 20n. So it is a perfect square, and it will factor into 2n minus 5 quantity squared.